So let's look now at naming acids. And when we're trying to make an acid or create an acid, many acids are actually made by just taking the gas form of a compound and dissolving it in water. We've already looked at writing the formulas for the compounds. So if we were looking at the formulas for the compound or the gas, we're going to use a little G to indicate that we're talking about the gas. And if we're talking about the acid, we're going to use AQ because it is in solution, in water. So an example here would be something like the gas form of HCl. The little g tells us we're talking about the gas. If we wanted to talk about HCl as an acid, we would have the exact same formula, but instead we would have an AQ. There's the difference between the gas and the acid. And remember, acids are all these H plus ions. So we're going to be looking for an H at the start and an AQ to determine if something is an acid. And once we know it's an acid, then we can start applying its name. And there's a variety of types of acids. Let's look at the first type, which are called binary acids. And these binary acids contain the H plus ion. And if we have a binary acid, here is our new naming convention. If the ion ends in IDE, we are going to change the name, put a hydro as the prefix and an ic as the suffix. Prefix is the start, ic is at the end. And let's show what that means here. Our last example there, HCl, if we wanted the name, this is hydrogen chloride. It's hydrogen chloride gas. Now, if we wanted to take and write the name of the acid, remember there's the acid because it has that AQ, we would take the IDE and replace it with an ic and put a hydro in front. Hydrochloric acid. Hydro is the prefix and ic is the suffix. Hydrochloric acid. Well, the reason that this is considered a binary acid is because it's just two elements. It's something with an H and some other element on the periodic table. And that's our first type, binary acids. Now the other type are going to be what are considered polyatomic acids. And polyatomic acids come from our polyatomic ions. You have a list in your data booklet, and these all contain oxygen. So we're going to be looking now at the list of polyatomics to name these. The naming conventions are a little bit different. If our original polyatomic ion ends in 8, we now just change the 8 to an ic as a suffix at the end. So an example here would be HNO3 as the gas. Now if we look this up, H is hydrogen, NO3 is nitrate. So if we wanted to write the name for the acid, the AQ, we would just change the 8 to an ic and we would have nitric acid. Well, some polyatomics actually don't end in 8, they end in ite. And if that's the case, then we change the ite to an us as the suffix. Again, here's an example, H2SO3 in the gas form. This is the compound, hydrogen sulfite. Now, if we wanted to write the name of the acid, the AQ form, we would take the ite and it becomes an us, and we have sulfurous acid. Sulfurous acid. Now notice we go back to the periodic table to put that UR in there. It's not sulfus, but sulfurous acid. Well, we can combine this all together in this little guide to naming acids. And again, the two types. First type is binary if it's hydrogen and an element, or another way you can think about it, there's no oxygen. Our naming conventions is we lose the "ide," we put a hydro in the front, and we put an ic on the end. If we have a polyatomic, and again, you can think of it on your list of polyatomic ions, or think of it with just oxygen. If we have an 8, it becomes an ic, and an ite to an us. And these are the key to naming acids. So you make a note, highlight that, circle that. We're going to use these as our examples, and we're going to do a series of examples on naming acids. Well, let's start with the first one. Here we go. HBrAQ. Well, right away, we can see that this is a binary. It is an element that has no oxygen and hydrogen. So if we look on our periodic table, H is hydrogen, Br is bromide. The two elements are hydrogen, bromide. Now if we use our naming conventions, the ide becomes an ic. We put a hydro in front, and we have hydrobromic acid. Well, what about H2SO4? Now, H2SO4, this is polyatomic. Notice we have oxygen right here. So we need to look up the names in this again. If you look on your data booklet, hydrogen is an H, SO4 is sulfate. So together they are hydrogen sulfate, but the acid name, the 8 becomes an ic, and we have sulfuric acid. So now I want you to take a second, pause this video, and see if you can do this example on your own. Well, HF is binary. Periodic table tells us that it's hydrogen and fluoride. So our name here would just be hydrofluoric acid, ide to ic. And try this last one again on your own. HNO2 is hydrogen and nitrite. Well, if we look at the ite convention, ite is going to become an us, and we'll just have nitrous acid. We also have naming conventions for bases and salts. The good part about this is that the naming rules do not change. Bases and salts follow the same naming rules as we've done before. It's just using the ionic names. The difference between a base and a salt and a compound, though, is having that AQ. So, NaNO3, if we're looking this on our periodic table, this is just sodium nitrate. And sodium nitrate, it doesn't have H or OH in the formula, so that would mean this is just a type of salt. If we did KCl, use your periodic table. We have potassium chloride. And again, there is no H and OH. This is just salt. Well, NaOH, AQ, again, this is either going to be a base or a salt. Well, the OH is actually going to come into play. That's going to tell us that this is sodium hydroxide. And because it has OH at the end, this is a base. Try the next one on your own. Here we have calcium and OH, calcium hydroxide. Again, we have that OH right here, which tells us it's a base. And what we're going to find for most of our bases, they're usually going to end in hydroxide. Most of the bases we're going to look at will end in hydroxide because they'll have this OH at the end. One last one. So try this last example on your own as well. Now this one, though, has a G, which means this isn't an acid, a base, or a salt. This is just hydrogen iodide, and if it's in the gas form, the G form, it is just a compound, which means it's neither an acid, nor a base, nor a salt. That G is very, very important. Well, if we have the name of the acid, we can actually work backwards to find the formula. So if we have the name hydrochloric acid, if we remember our naming conventions, we can actually use our naming conventions because we have a hydro and an ic, which tells us we have a binary. It's going to be hydrogen with some element. And our element then is going to be the ide instead of the ic. So what does that mean? We are going to have hydrogen and chloride, which comes from chlorine. So if we're writing the chemical formula, hydrogen is a 1 plus, chlorine is a 1 minus, and the formula then would be HCl, and because it's an acid, we have AQ. Very similar if we have a base, calcium hydroxide. Notice the name doesn't say acid, so we know it's a base. Calcium hydroxide, there's no need for our guide. All we have to do is look on the periodic table and look on our list of polyatomic ions. Calcium is a 2 plus, hydroxide is a minus or a 1 minus, which means we'll need 2 hydroxide to balance the charges. And we have the chemical formula CaOH2, again with that AQ, because we have a base. See if you can write the formula for the name nitric acid. Well, nitric acid, using our guide. There's no hydro, so we're going to see that ic came from 8. So nitric came from nitrate. Because it's an acid, you know it's going to start with hydrogen. So we look on our list of polyatomics, and nitrate is NO3. Notice the charge here is a minus, hydrogen is a plus. So we need one of each, and our chemical formula for nitric acid is HNO3AQ. One last one. See if you can try hydrogen bromide. Well, remember, hydrogen bromide, notice the name, there's no ic, which means we're not talking about an acid or a base or a salt. This is just using our regular naming conventions, so all we have to do is look up hydrogen and bromide, and we get the formula HBr, and remember, because it's not an acid, a base, or a salt, it has that little g. And that's our naming conventions for acids, bases, and salts.